So the next thing I want to talk about is how you calculate a limit. We're going to do some examples, but I just want to give you the basic rules and to show you how in many cases this is not actually that hard to do. Obviously there are some where it is, but for the vast majority of limits are actually not that hard to calculate. So the simplest rule is if p of x is a polynomial, then the limit as x approaches c of p of x is equal to p of c. So what does that mean? Well, a polynomial is something like this. A polynomial is an expression of the form it's where it's just multiples of integer powers of x. So it's an expression of the form a0 plus a1x plus a2x squared plus dot 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 plus an x to the n. I know that looks fairly complicated, but I'll show you some very simple polynomials that you know. So examples are, for example, y equals x squared plus 5, or for that matter, just y equals x squared. You can easily see that this meets the definition because the a's are constants and then x's are just powers of x. So this is like equal to 5 plus 1x squared. And of course, all the other coefficients are 0. So if I'm just adding up integer powers of x, then I have integer non-negative powers of x, I should say. So, by the way, let me just erase this so I have some more room. If you're wondering where that 5 comes from, keep in mind that 5 can be viewed as 5 times x to the 0, and then we have 0 x to the 1, and then 1x to the 2. So this is a polynomial. So some other examples of polynomials would be just y equals x squared, or even y equals 7, because a constant function is just like y equals 7 times x to the 0, so it's a polynomial. So this includes a very, very large class of functions that you already know about, and the rule is very simple. If I want to know, for example, what is the limit as x approaches 1 of x to the 15th plus 7x to the 4th plus 3, that's just going to equal, all I have to do is just replace the approach point 1, replace x with that, and I get 1 to the 15th plus 7 times 1 to the 4th, that's a 7, plus 3, so that equals 1 plus 7 plus 3, and this is 11. So that's rule 1, and it covers a very large number of situations of limits that you're going to be evaluating. Rule number 2 kind of expands this to a wider universe of functions. So it's just that the thing about polynomials is that they're defined every place. So I've got to put in a little bit of a caveat with some of the other functions. So if f of x is one of the following types of functions, either a trig function, an inverse trig function, an exponential function, or a logarithmic function, and if f is defined at c, then we can do the same trick. We can just replace, we can just replace x with c in the original expression. Just so, for example, the limit as x approaches pi over 3 of sine x is equal to the sine of pi over 3, which you should all know is root 3 over 2. So this works with a very large class of functions: trig, inverse trig, exponential, and logarithmic. You can just replace them. Oh, and by the way, the most important of the exponential functions, I didn't want to use it because I don't want to apply all exponential functions to this function, but the most important of the exponential functions is y equals e to the x. So that's just another example of a limit you can evaluate by substitution. These rules together are called substitution. In other words, we're just taking in the expression, say, limit as x approaches 2 of x squared plus 1, we're simply taking this value and substituting it in wherever we see x, so that's going to equal 2 squared plus 1, which is 5.